Analytic geometry is a branch of mathematics taught in technical colleges and universities starting from the first semester of the first year. This is because analytic geometry is a fundamental mathematical discipline. A confident command of the language and methods of analytic geometry is a prerequisite for studying other areas of higher mathematics and physics. It's also worth adding that analytic geometry is, perhaps, the most beautiful branch of mathematics. Let me show you the utility, power, and beauty of analytic geometry with a specific example. Example: finding a line intersecting two skew lines. Given the equations of two skew lines, L1 and L2. Find the equation of a line L that passes through a given point C and intersects both lines L1 and L2. This analytic geometry problem is related to a problem in theoretical mechanics. It turns out that line L is a line of zero moment of forces. In theoretical mechanics, it's proven that an arbitrary spatial system of forces is equivalent to two forces, F1 and F2, which generally do not lie in the same plane. Obviously, any line intersecting the lines of action of forces F1 and F2 will be a line of zero moment of forces. If we set ourselves the task of finding a line of zero moment of forces passing through a given point C, we arrive precisely at our analytic geometry problem of finding the equation of line L, which passes through a given point C and intersects the skew lines L1 and L2. Now, please take a look at this elegant solution to the analytic geometry problem. I won't explain the solution in detail. To do so, I would have to explain what scalar and vector products of vectors are, and what the parametric form of a line equation is. But all of that has long been written in hundreds of textbooks and problem-solving guides on analytic geometry, and it is clearly explained and demonstrated in hundreds of videos on YouTube. The purpose of this video is only to show you, through a specific example, the power and beauty of analytic geometry. I'll just note that in the solution, points are denoted by capital letters, and vectors by lowercase letters. The parameter is denoted by the letter t. The solution is vector-based. No coordinates are introduced at all. Therefore, the solution can be constructed purely geometrically, using only a ruler and a protractor, based on the vector formula obtained algebraically. However, in practice, we usually need to find the numerical values of the required quantities. To do this, in our case, having the answer in vector form, we only need to introduce a coordinate system and calculate the necessary quantities manually or using one of the computer algebra systems. We will use the GeoGebra program. It's probably one of the most convenient and user-friendly computer mathematics systems available today. GeoGebra is a program for precise and approximate calculations and precise geometric constructions. I always tell my students, who are glued to their smartphones playing computer games, on that same phone, go to the GeoGebra website and just draw something. For example, how a cube intersects a plane. Make drawings for your physics and geometry problems in GeoGebra. The results will be high quality, interesting, and very beautiful. And do you know why it will be very beautiful? Because the software engineers for graphical software, and in particular the developers of GeoGebra, use all the power and beauty of analytic geometry in their program code.